So. Mhm. Okay, hi everyone. So I'm actually, I think most of you have been in the previous talk, so I'm continuing some things from over there, picking up on the last slides and elaborating a bit over there. So, how should I? Really? Oh my fucking. No, that didn't. Oh, yes. Okay. I hit the space first. Okay, so some background first. Well, there's quite a lot of history here in this in this slide. At first, we used to use Xinput 1, which was a really hard to use API in order to handle drawing tablets. And besides that, we used core events from X in order to receive events from mice and keyboards and such. But then Xinput 2 arrived, and well, it was quite a revolution. I mean, it's properly designed API, or it was at the time. And it really helped GTK evolve a lot in how it handled input devices. And it was adopted in GTK 3.0, actually. And then after that, well, we got Xinput 2.2, which is, well, an extension on the previous API, which basically added touch support and smooth scroll events, which were adopted by GTK 3.4 at the time. So, well, since then, we had some sort of touch support and smooth scrolling. The touch support was quite weak at the moment because we just forwarded touch events, as in, well, in the Xinput API is touch, its finger would have an associated sequence ID. So it would just, well, you get receive different streams of events with different IDs, and we just forwarded that to the applications. But we did no interpretation whatsoever on these events. So applications were free to use it, but no application used it in the end, unfortunately. But that situation has changed somewhat, and one thing that has helped a lot was the introduction of gestures in GTK 3.14. And gestures might be here maybe overused term or something, because as opposed to the common knowledge about gestures, these do handle or involve both touch or mice. So, I mean, a long press is either a long press on a touch screen or a long press on a mouse button. The code doesn't really care for that. It can handle both mice and touch screens. So the thing is that these gesture objects are simple enough and isolated enough, so you can use and mix them and try to make higher level behavior out of that. And it's almost integrally used in GTK, so you can imagine this. I mean, almost every widget now uses gestures underneath in order to handle pointer events or touch events. So you're if you are using GTK apps, you are using gestures right now, even if you don't know. And another change that got around that time was the introduction of cell-level gestures, which is basically mostly the same, but for the cell. So you could, well, for example, two-finger gestures are mostly restricted to the application. They are of no interest to the window manager, for example, but 3 or 4 finger gestures are basically meaningless for most applications, and they might be interesting in order to add functionality to the window manager or compositor. So what we did is adding a few gestures like switching workspaces or showing the overview or changing the focus tab. And that stuff you can do now without keyboard or mouse, which is also positive. And this was introduced around the same time in Matter 3.14, so it got everything together in GNOME 3.14. So, well, it was quite a change back then. Well, not long ago, actually. But then, well, I've been talking mostly about X, and well, desktop environments have been traditionally based on X11 and using its details. But now Wayland has come. Well, I guess many of you know Wayland. I don't know do you know about the layout of how things work. But regarding input, thing is that the input is taken by the compositor and then redirected to our applications, but something has to read the event nodes. It was actually done initially by Weston, which is an implementation of Wayland. And that code was split into Libinput. I'm not going to get again into Hans's talk. And so far, this Libinput handles keyboards, mice, and touchscreens. That's right. Mostly right. Okay. So, things is that Wayland in general, Libinput concretely, is introducing changes in how input devices are dealt with in every level, basically. So, let's try to go back again to X11. I mean, there's quite some history and knowledge that has to be applied somewhere. So, the thing is that X11 is the X server is something that takes events on one side, delivers them to the other side, and then it basically lets any client implement things on top of this behavior. So one client can be a window manager, another client can be just a regular browser or whatever. But everything is an X client. So you get first the X11 drivers, which read the event nodes. They translate the input event structs and post them to the X server. And these drivers, they also create public properties in order to toggle stuff on or on, like natural scrolling, as Hans was showing with X input list props command. But those properties are actually public for anyone to consume or read or whatever. And then GNOME settings daemon would actually play the role of modifying these properties. It would read the settings on one hand and apply this to the X devices on the other hand. And, well, the thing is that, this is one detail of Wayland versus X11 is that, X11 is very happy at making resources public. So you can actually, in theory, when you click on a window, it's actually that window receiving the event, but other clients could actually also try to connect to that window and try to receive their own set of events for that stuff. So That's why I say that any client could receive the event. And that's, in theory, how input works. On one hand, there's events that get to the client through some path, and then there's configuration, which is exposed by the drivers. But then on Wayland, things are slightly different, and it's the compositor which is responsible of the delivery of events. There's no intermediary, no intermediate layer. So here is it's the compositor which talks directly with Libinput and forwards the event to the right client, to the single right client, which is underneath your mouse or touch. And the main thing here, on one hand, this is a better design overall, as in better encapsulation for applications, etc. But the downside here is that these device properties and toggles aren't public anymore. So they have to be on some way handled by Matter itself or by whatever compositor is implementing the Wayland protocol. So the thing here is that instead of having a separate daemon, which is, let's compare with the previous slide, here it was GNOME settings daemon, which was taking the settings and applying this as X-device properties. And on Wayland, it's Matter directly, which reads the settings and applies directly to Libinput, because the change is done by API, not by protocol calls or anything. This is already done and is scheduled for GNOME 3.16. And actually, the same pattern that we are exposing here is used also on X11. So we've made the change for our sanity, mainly, because we are also still aiming to run on X11. And the idea is that GNOME settings daemon can't go, but it can be left with the legacy stuff. As in, the idea is that Matter controls every Libinput device, either both on Wayland or on X11 through the Libinput driver. And GNOME settings daemon still gets to talk with the old drivers, synaptics, and everything. And so even users of really old setups or clunky users who don't want such update for whatever reason, they can still get things working. So this is something that Hans already elaborated a bit. What is currently missing here, and there has been no time for 3.16, is actually the real UI itself, as in GNOME Control Center has some special requirements because it needs to show you on the UI the settings of the devices to which you have currently connected. But the fun part here in Wayland, which is positive and somewhat annoying maybe in this regard, but it can be worked around, evidently. The thing is in Wayland is that you just get you get a WL seed, which has a pointer, may or may not have a pointer, a keyboard, or a touch device. And you don't know anything about it. You don't know about how many mice you have connected, or whether you have a touchpad or you don't. You don't know anything as a Wayland client. So the idea is to have a Libinput helper, which basically dumps the configuration options that are available on udev. So GNOME Control Center can actually poke udev and get the list of devices, can get the set of features that they have, and can update the UI accordingly. But that's still missing. I don't think there's time for any more Libinput releases until GNOME 3.16. So it will be very hard to get it. But will be for the next release anyway. So right now what you would get is just, you could get all options that you might get even if your touchpad doesn't support two-finger scrolling. You could still get the option enabled as unselectable, but that's a downside so far. So this has been the present. This has been mostly an update of what's to come very shortly in GNOME 3.16. And the short-term future is, well, there's quite a few things in the staging areas, as in tablet support, as has said. There's branches all through all affected modules. So there's a Libinput branch with which has the API. There's a proposal for a WL tablet protocol for Wayland, which caters quite nicely with all the intricacies of these kind of devices, and well, and the weird setups that you can have, because, well, you know, the designers can have like multiple monitors and multiple tablets connected, and then you need to map to different monitors and whatnot, for example. So the protocol actually caters quite well for that, for the availability of multiple devices or different features in each device, and it's already there. And on the GNOME side, there's branches for Clutter, because Clutter is the library, the graphics library, well, the toolkit, I wouldn't dare to call it like that. But it's the toolkit used by Matter in order to render stuff on the screen and receive events from. So the EBDEV backend of Clutter, there's already a branch for that in order to support this Libinput API. And there's a branch also for Matter, which picks these events from Clutter and then transforms them into protocol messages which are sent to the client and everything. So, well, I think I'm talking about the next slide, actually. But yeah, things are getting along nicely over there. So I would hope that they get merged very soon, you know, after 3.16 is branched, so we can start hacking on GNOME 3.18. And that will be very soon after 3.16 is released in this. So I'll skip to this one. But there's still some things missing, as in, well, as I said, these kind of devices, they are pretty intricate. On one hand, you've got the Stylus, which has pressure sensibility, or it has can detect the distance from between the pen and the tablet. It can detect the tilt of the pen in both axes. So the Stylus itself is quite an intricate pointing device, but then tablets have buttons on the sides most usually, so you can set some button in order to do something, which is, well, this is a gray area in GNOME right now, because, well, you can do that, but currently you can just assign key bindings to one button. So you can make one button to emit Control A, so it selects everything, or you can make one button to make to be the shift modifier. So you can in GIMP paint and you can, when you press shift, I think it's the shift key, you can move the image. So, but this mapping of buttons to actions is a bit limited, because, well, it's on one hand not flat across applications. For example, I don't know, GIMP, it may have some key some accelerator for one feature, but it might be different from the same feature in Inkscape, for example. So it's limited in some way, specific to the user setup and the applications that he uses. So it's something that we would like to improve there and make actually something that would expose a common set, well, not common, but rather a standard set of actions for applications to handle. So, for example, you can move image or select or whatever, and all applications would ideally behave the same with that button. And then there's also this nitpick about tablet buttons, because there's indeed some actions that could be interesting to handle from the compositor. So you've got doubly handling of buttons here, which is somewhat interesting, and again depends on the user setup and everything and how he maps buttons, because there's no tradition. We know that the left button in a mouse is the button 1, and you can use it to select things, but there's no associated action to these buttons in tablets, so people can do whatever they want in the end. And tablets, they also have these tactile wheels or stripes, or so they actually provide different access. So, for example, you could use the wheel in order to rotate the image or zoom into it or whatever. But again, this is currently done by just delivering, translating this stuff into keyboard events, which is not most ideal for applications. So this is some things that would be nice to get better, but they are partly on purpose left aside in the protocol so far. So, well, we currently support in these branches Stylus and everything about them, but, well, buttons we are still a bit rough, and then the wheels and stripes, they still need support from Libinput itself. So, next thing that the short-term future might bring is proper kinetic scrolling. I mean, I've heard infinite complaints about, yeah, well, if I swipe fast on the touchpad on this view and then Alt-Tab, I can get the kinetic scrolling running on the other applications I'm focusing to. But that's actually I don't know who had this idea indeed. I mean, it's currently it's the Synaptics driver which is actually doing the kinetic scrolling, but it lacks whatsoever any context about what you are doing or which is the window which is receiving the events, nor anything. So it's a very bad place in the end to have kinetic scrolling working. Because basically you get things like that. You can move to another window and then get the flurry of events over there. So the idea is that Libinput, there's API right now for that. There's no Wayland protocol yet. But the idea is that Libinput on scroll events, it's able to tell you the source of the device which is causing scroll events. So the idea is that you can know whether it's a mouse or whether it's a button mapped to something, but the interesting thing is that you can find out whether it's fingers on a touchpad which are causing the scroll. So you can actually get to hook to the last event of scrolling and get to know, okay, this is a finger kind of device. This is the last scroll event I'm getting, so I now trigger kinetic scrolling, and this is done on GTK or on Qt or whatever. So this would basically fix every kinetic scroll complaint I've heard during these last years. And then there's more stuff on the works. Hans has been doing a lot here, and well, there's more work left to do in this. But the idea is to support touchpad gestures, both in the compositor, same than touchscreens, both in the compositor and in applications. So the idea here is that, the requirements for touchscreens, they are touch devices, touchscreens and touchpads, but the way you use them don't map one by one with the other. So the idea here is that gestures are largely simplified to what we do, for example, in GTK with touch events, with gestures. And it would be Libinput the responsible for doing the interpretations of these events and giving you some high-level interpretation of this, such as the user is zooming or is rotating, or this is a three-finger swipe or whatever. And the idea is to, once there is Wayland scaffolding for this, the idea would be to have this wrapped by GTK gestures. So people just use the gestures, and the gesture object itself just receives one kind of event or the other, and it doesn't matter to the user in the end. So, oh shit, I'm going too fast, I think. Okay, so in the longer term future, this so far have been items that they aren't done yet, but there's code somewhere for this. So these are likely to get done in a short, in a short mid-term future, as in 3.18 or 3.20 or something like that. And the idea here is, well, in the longer term future, there's still some missing details. I mean, for example, tablet mode switch, there's a few devices which are foldable, or these tablet laptops and everything, which they actually give, through an input node, even node, they actually raise a flag on whenever you actually fold completely the laptop. So you could actually get it to ignore the touchpad, which is still working behind, or you could make the compositor rotate the display automatically. So there's some interest in having these handles, but this has been mostly in the talks only so far. But it seems like Libinput and on Matter seems on Wayland, it seems like a proper place to have this done at last, because on X11 there's no right place in the end to have this done properly, because these kind of event nodes, they are ignored by X, because they trigger nothing that could be interesting to X in regards of translating this to any events. It has no display rotation event, evidently, so there's no right place in the end to have this done on X11. So, and then there's a few more lingering areas, but I would say that this will require less and less changes from Matter or GTK. I mean, you could want to handle, as we talk, with devices, or this HDMI consumer electronics controller thing, but this could be in the end pointer devices or keyboard devices or whatever to the upper layers. So that could be mostly work left in Libinput. And yeah, well, I've talked too fast, I guess, or I don't know. So any questions about how having things done? Yeah.
So you have been talking about tablets,
Mm-hmm.
but
Uh-huh.
I think that, well, is there any plan to make the touchscreen support properly implemented? The thing is, I can show you. I have Kinetic here.
Mm-hmm.
And here Kinetic scrolling, and everything works fine.
Mm-hmm.
But in GNOME terminal, I'm just selecting text.
Yes. Okay.
It's just annoying, you know.
Yeah, no, but that's kind of different. I mean, well, the question was about whether touchscreens will be properly supported, and the thing is that they already are. They already are. I mean, as you see, gedit is as much of a GTK3 application as GNOME Terminal is, but GNOME Terminal doesn't use GTK scroll window, which is the part that implements this touch scroll thing. So they do something which looks similar, but it's not the same. So they basically ignore touch events so far. I think, Rishi, you had a patch for that, right? Cool.
So the answer is wait for the Wayland?
No. The answer is wait for GNOME terminal maintainers to get something done, basically. But I mean, the touchscreen support is quite complete. I mean, you can even plug different monitors with different touchscreens, and each device gets mapped to the right coordinates and everything. So it's made to just work, but it's applications which still need supporting this in some way.
Thank you.
Any further questions? Okay. Sorry.
Do you work on input device configuration and control panels?
For GNOME Control Center, you mean?
Do we work on control panel applets for configuring input devices?
But panels for what environment?
For example, graphics tables.
Yes. Well.
This like a configuration tablet.
Mm-hmm.
It uses slip backend directly.
Uh-huh.
Do you plan to make it more generic? Work with other tablets?
Mm.
Or is it like
But I fear I didn't get your setup.
For example, I have non-backend graphics tablet, and currently it works with x386 keyboard EVDEF,
Uh-huh.
and it sends some basic events. And it would be nice to have the ability to map it to some screen, for example, or
Uh-huh.
change the curve,
Mm-hmm.
the pressure curve.
Yeah. Yeah. The thing is that.
Rotation or something.
Uh-huh.
So for now, users are like forced to use EVDEF like driver properties.
Mm-hmm.
And it's not very convenient. But what
Yeah.
direction would you like to take that?
Yeah. Right. So the question was basically how good tablet configuration change with compared to the old EVDEF driver or anything. First of all, I would say that you should be encouraged to use the Wacom driver itself because it has already properties for such stuff and is handled by GNOME Control Center. So the thing is that EVDEF is a so generic driver that it doesn't have any. Nowadays, it foreseeably won't have such properties.
Yeah, I'm just asking what do you think, like where should we go?
Uh-huh.
Should we do with these tablets?
Yeah, but I think that basically the Libinput driver approach is mostly fine, as in exposing properties on X11 and having Matter toggle this. So the same approach should work with Wacom tablets, indeed. Any further questions? Okay, that's a recess then.
If no one else has a question, then I have a question. Your last slide, you were talking about the tablet mode switch. So you have a convertible, and you want to detect whether it's in tablet mode or in regular laptop mode.
Yep.
Have you already any ideas how you want to do that? Because I've been thinking about it myself, and I was wondering if you have any ideas how to do that? And especially, do you also want to support it under X? Or do you only think only Wayland because X is still very much not that?
I mean, I've personally tried to get this done. My previous laptop was a tablet laptop. And I personally tried to get this done all through the stack, and I never hit the right place to have this done.
So my idea is to use UDEF properties, because I heard that that's how rotation works. If you have a tablet and it's
Yes.
rotation, it sets a UDEF property.
Yes.
You could easily do the same for the tablet switch, even at the kernel level.
I tried to submit a patch to the kernel so the platform drivers could emit an UDEF event when the change could happen. But it was dismissed as a potential performance hog because UDEF events are a bit slow, and you could conceivably try to open and close very quick, and it was whatever reason, but it was dismissed because of that.
Should we give it another try?
Maybe.
I still think that's the best thing, and it will also work with X11.
Yeah, maybe. I think I still have the patches around.
Oh, great. We need to go after that.
Yeah, no, I mean, having UDEF would be perfect for our point of view as well, but if there's no, that can be done, I'm shorter of time.
We still need to fill 5 minutes, so.
Yeah, exactly.
No, I have no further questions.
That's it, I think. Thank you.
1, 2, 3. 1, 2, 3. 1, 2, 3. Blah 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 blah. Okay, that works.